Electricity and magnetism are inseparable partners. Did you know that a simple flow of electricity can generate an invisible force field? This is the realm of Ampere's law, a fundamental rule that reveals the connection between moving charges and magnetism. Ampere's law is a fundamental principle of electromagnetism, describing the relationship between electric currents and the magnetic fields they create. It states the magnetic field created by an electric current is proportional to the size of that electric current, with a constant of proportionality equal to the permeability of free space.
Historical context. In the 19th century, as a scientist explored the link between electricity and magnetism, Marie Ampere meticulously conducted experiments. She observed a crucial pattern that the stronger the electric current flowing through a wire, the stronger the magnetic field it induces around itself. So, mas malakas ang electric current through a wire, mas malakas ang magnetic field. So, yun po. Ampere's genius law of formulating this observation into a powerful law. Ampere's law states that the strength of a magnetic field around a closed loop is directly proportional to the current passing through the loop. For example, when you connect two ends of a wire to a battery and wrap the wire into a coil, the current flowing through the wire produces a magnetic field around the coil. The magnetic field can attract or repel nearby magnetic objects, demonstrating the relationship between the electric current and the strength of magnetic field in accordance with the Ampere's law. Importantly, the right-hand rule helps us determine the direction of this magnetic field. Imagine gripping the wire with the right hand of your thumb pointing in the direction where the current flows. Your curling fingers will indicate the direction of magnetic field.
So this is the equation of Ampere's law. Closed loop integral of V times dl equals to the constant mu 0 multiplied by how much current is enclosed by this loop. So we now be moving on to the Ampere's law equation. V denotes the magnetic field. Then the dl represents a tiny segment along the closed loop. Then the U0 is the permeability of free space, a physical constant. Then the I is the enclosed electric current. The closed loop integral means we sum up the magnetic field contributions along the entire loop.
Here is the application of Ampere's law in real world. So first, electric motors and generators rely on this principle for their operation. Next is medical imaging technologies like MRIs utilize powerful magnetic fields made possible to calculate accurately thanks to the Ampere's law. And lastly, scientific research involves massive electromagnets to study particle behavior. Ampere's law is crucial in their design. So to summarize, Ampere's law is the magnetic field created by an electric current is proportional to the size of that electric current, with a constant of proportionality equal to the permeability of free space. Next is, it is named after Marie Ampere. And lastly, its equation is the integral of the magnetic field dotted with a differential length vector is equal to the permeability of free space times the current enclosed.